So today we're going to explore molar mass and the calculation of molar mass. And let's dive right into this problem. What is molar mass? Molar mass is the amount of grams per mole that a chemical compound can weigh. So let's first review. 1 mole is equal to 6.022 times 10 to the 23rd molecules or atoms in a substance or a compound or a single element. And depending on the actual elements involved in the compound is the molar mass that we get. How do we get the molar mass? Well, in the periodic table we have the atomic mass of each element. And for example, depends on the periodic table you're using, but let's say hydrogen has an atomic mass of 1.01 grams per mole. So the little numbers that you get in the periodic table are precisely atomic masses, okay? So we need a periodic table to pull through with these exercises. Another element, oxygen for example, let's say that rounded it's 15.99 grams per mole. And these are atomic masses. Once we actually get a compound, for example, water, we have to analyze water to see how much it weighs. So the simplest way to do this would be to break it up into its constituent elements. For example, hydrogen and oxygen, and then we count how many hydrogen atoms are in a water molecule. There are 2 of them, so times 2, and there's 1 oxygen atom. And then the next thing we would include here is the actual atomic mass of each of these individual atoms, okay? Grams per mole and 15.99 grams per mole. So if we are to punch that into our calculator, chemistry is a subject that requires a calculator for many of the problems that we do. We multiply 2 times 1.01, 1 times 15.99, and we add all of these together. So a big plus sign. So at the end, the molar mass of water is 18.01 grams for every mole, meaning that 6.022 times 10 to the 23rd molecules of water are going to weigh 18 grams, which is the same as 1 mole of water specifically. So let's try another example. Remember, molar mass is going to vary depending on the compound that we have. Let's try another compound which might not be, well, it is simple, but let's just try to figure out. Here we have aluminum hydride. So again, we do our little inventory of atoms. We have aluminum, we have hydrogen, 1 aluminum atom and 3 hydrogen atoms times their atomic mass that we get from our periodic table. We know this one by heart, 1.01 grams per mole for hydrogen. And then I look at my table for aluminum and it gives me 26.98 grams per mole. And once I go ahead and I punch that into the calculator, I'm going to get 1.01 times 3 plus 26.98. And that gives me a grand total of 30.01 grams per mole, which is a specific molar mass for aluminum hydride. Okay? How can this get tricky? Let's say we have other compounds which are a little bit more complicated. Let's say something like, let's try magnesium phosphate. So this is where the counting gets tricky, right? Because of the valence, remember magnesium was +2, phosphate is -3. We do the crisscross and this is what we get. So we're going to start having bigger numbers. We have magnesium, phosphorus, and oxygen. But this is the tricky part once we actually do the counting. So how many magnesium atoms? There are 3 magnesium atoms. There are, for every phosphate, 1 phosphorus atom, but there's 2 of these phosphates in this molecule, so there's 2 of them. And last but not least, for every phosphate, there's 4 oxygen atoms. But since there's a 2 outside the parentheses, it multiplies everything inside. And what are we going to get? We're going to get 8 oxygen atoms times the atomic masses that we have from the periodic table, 15.99 grams per mole. Then for phosphorus, I take my table and it's 30.97 grams per mole. And for magnesium is 24.31. So again, what we would do is we multiply everything and then we add all the independent elements together. So I take my calculator and I'm going to go ahead, 24.31 times 3 plus, remember to use your parentheses, that always helps so that we don't make any mistakes, and 30.97. And then we add the 15.99 times 8. And if you punched everything right into your calculator, you're going to get 262.79 grams per mole, which is the specific molar mass for magnesium phosphate. So we can do many other exercises, but really the actual trick of this is in the counting, okay? Let's try another really quick example. Let's say you have a hydrocarbon such as, I'm thinking butane, C4H10. Very simple. Once again, carbon, hydrogen, times 4 from the formula, and then times 10 from the hydrogen as well, times 1.01 grams per mole. Carbon weighs 12.01 grams per mole, and we plug that into our calculator again. 4 times 12.01 plus 10 times 1.01, and we get that butane weighs 58.14 grams per mole. So make sure to challenge yourselves and take some compounds which need a little bit more multiplication, and it's very simple to calculate molar masses when we have a periodic table and our calculator ready to go.